So I got 3 plus 4i minus 5 minus 7. And I'm back on familiar turf. Combine like terms. 3 minus 5, 2. 4i minus 7i. Is that okay? You gotta admit that's not too challenging. Adding, subtracting these complex numbers, just treat the i's as if they were variables. Combine like terms, you got it. It gets a little more interesting, there's the euphemism, a little more interesting when we start multiplying these guys. In fact, let's multiply these two guys. And I go right back to my multiplying polynomials. I got a binomial times a binomial. What method am I going to use? FOIL. Just like I always have. Here we go. Remember to treat the I as if it's a variable. 3 times 5 is 15. 3 times 7i is 21i. Plus 20i. Plus 28i squared. Just like it's a variable. And like in almost every FOIL, the middle two terms will combine. So let's do that. Here's the one thing you have to remember that distinguishes an I from any other variable. You'll never leave an I squared as part of your answer. Your final answer will never contain an I squared. Why? Because I squared will from now on be defined as?
1.
One of those.
Negative 1.
Negative 1. I squared is going to be defined as negative 1. Remember your first definition? Square root of negative 1 is I. Well, here's your second definition. That is that I squared is the same as negative 1. So with those two definitions under your belt, you ought to be able to handle just about anything that complex numbers throws your way. I squared is negative 1. So everywhere I have an I squared, I'm going to substitute negative 1. So now I have 15 minus 28 plus 41i. Notice that this is just a real number now. 28 times negative 1, that's just negative 28. So I got the negative 13 plus 41. And it will ask you to put your answers in standard form, which means real number first, I's second. Everybody got a question there? But the bottom line is, hey, you encounter an I squared, you're not finished. I squared says substitute negative 1 before you go any further. Got that? Right, let's look at an example of division involving complex numbers. One thing we have to mention is this. That just as